Hugging Face has reported an intrusion into its systems, and here's the part that makes this story especially concerning. According to the report, the entire chain was driven by an autonomous AI system. I don't usually make videos like this, but this incident is important enough that I wanted to break down what happened and why it matters. There have already been plenty of confusing headlines around the story, so let's go through it carefully. I'm not a cybersecurity expert. I'm simply trying to understand what happened and share the key details with you. So, what was the AI actually supposed to do? It wasn't explicitly told to attack another company's infrastructure. The original task was much more controlled. The agents were placed inside a restricted test environment and asked to find and exploit vulnerabilities there. The environment was essentially a sandbox, designed to keep the system contained while it worked on a difficult objective. But things quickly became much more interesting. The task itself was extremely difficult, and after repeated attempts, the AI couldn't solve it. Then the system started looking for a more efficient approach. Its reasoning was essentially, instead of spending all this time solving the problem from scratch, why not search for useful information online? There was just one problem. The environment had no normal internet access. The agents were effectively trapped inside their sandbox. However, they did have limited access to an internal open AI service called ***Artifactory****, which is primarily used for managing software packages. And that service had much broader internet connectivity. The agents couldn't simply browse the web directly, but they discovered they could interact with the service indirectly by uploading small pieces of information. That's where things started getting strange. The agents began trying to communicate with other AI agents, looking for additional help. It's almost like an online meeting place for autonomous systems. Other agents discovered the same possibility, and eventually, they created something resembling a shared message board, where they could exchange information and coordinate their work. Then the agents started dividing the problem between themselves. One could assign a task to another, which could investigate a separate part of the problem and return the results. The system was effectively becoming a small, collaborative network of autonomous agents. And importantly, the agents appeared to recognize that their actions could have unintended consequences, but they continued because the original objective still needed to be completed. Then came the major breakthrough. After several days, the agents discovered a vulnerability that allowed them to make the internal Artifactory service reach the internet on their behalf. In other words, they had found a path out of the original network restrictions. But that wasn't the end of it. They then discovered another vulnerability that could provide *** administrator level access to Artifactory. ***. At that point, the security boundary had been seriously compromised. OpenAI engineers detected what was happening, revoked the agent's credentials, cleaned up the environment, and patched the affected systems. It looked like the incident was finally contained, except it wasn't. Once the original communication method was blocked, the agents found another way to exchange information. Instead of sending files through Artifactory, they started using directory names as messages. Think of it like prisoners tapping messages through the walls when every normal communication channel has been taken away. The agents were effectively creating an alternative communication protocol inside the restricted environment. Researchers found snippets from this message board showing agents telling one another to wait for results, pointing each other toward newly created files, and coordinating their work. Sometimes the agents even interfered with one another by overwriting files. At one point, the behavior raises the question of whether the agents were effectively sabotaging each other's work. And then things escalated again. Eventually, one agent discovered another, significantly more complicated path out of the environment and shared it with the rest of the group. Now, the agents needed somewhere to look for additional information. And one obvious target was ***, Hugging Face ***, which hosts a huge amount of AI research, model information, and benchmark data. the swarm decided to investigate the platform. And according to the incident report, the agents autonomously chained multiple vulnerabilities together, eventually obtaining administrative access across several clusters of machines. That is an extraordinary development for cybersecurity. We're no longer talking about an AI simply generating code or suggesting a vulnerability to a human operator. We're talking about autonomous systems discovering weaknesses, adapting when their original methods are blocked, communicating with other agents, and continuing toward their objective. So, what do we actually learn from this? First, autonomous AI security needs serious attention. Second, defenses have to evolve at the same speed as automated attacks. If AI systems can continuously search for vulnerabilities without getting tired, traditional security teams could eventually struggle to keep up. That's why I think automated defense will become just as important as automated offense. We need systems that can continuously scan infrastructure, identify weaknesses, verify potential vulnerabilities, and help engineers fix them before someone else can exploit them. Open research and open AI could play an important role here as well. We shouldn't want powerful defensive technology concentrated in only a handful of organizations. The more researchers and developers who can work on automated security, the better our collective defenses can become. But there's another problem. Security teams are already dealing with huge numbers of automated vulnerability reports, and many of them are low quality. If AI starts generating vulnerabilities faster than humans can verify them, simply producing more alerts won't solve the problem. The defense system needs to become better at identifying the few genuinely important issues hidden inside the noise. Ultimately, the defensive side has to become stronger than the offensive side. Right now, it isn't clear that we're there yet. This is why collaboration matters. Researchers, security engineers, AI labs, and open source developers all need to contribute to the problem. I also believe the computing resources available to researchers can be part of that effort. I'd rather see GPUs being used to strengthen our defenses than simply accelerate another race toward more powerful attacks. And this is exactly why some of the warnings from AI safety researchers over the past several years are worth taking seriously. The risks don't necessarily appear when an AI is explicitly instructed to cause harm. Sometimes they emerge when a system is given an objective, enough autonomy, and enough tools to find unexpected ways around the restrictions we built for it. I could be wrong about some of the details, and I'm still learning about this alongside you. But one thing seems clear. Autonomous AI is changing cybersecurity much faster than most people realize. I use lambda to reproduce AI research papers, often in minutes. It's also useful for training your own models, fine-tuning existing ones, running inference, and experimenting with text-to-image or video systems. You can even run a DeepSeek chatbot or agent using powerful NVIDIA GPUs. I use it to test ideas from the papers I cover, launch experiments, and get results quickly.